Hello children, I'm doing 10th class SSC previous questions. I have done up to 7 problems in the previous video. Now 8th problem. Use Euclid's division. Use Euclid's division lemma to show that square of any positive integer, square of any positive integer is of the form of 5n or 5n plus 1 or 5n plus 4, where n is a whole number. This is the problem, children. Now let us see what is Euclid's division lemma. What is it? A is equal to BQ plus R, where 0 less than equal to or less than B. According to problem, what is B? 5n? 5n plus 1? They said no. B is equal to 5. Therefore, what is our 0, 1, 2, 3, 4? So, let us take one by one. If R is equal to 0, then A is equal to BQ plus R. This implies A is equal to 5Q plus 0. That is equal to A is equal to 5Q. Now, what does the problem says? Square of any, that means A square is equal to 5Q whole square. That means 25Q square can be written as 5 into 5Q square. That is nothing but 5n. Therefore, A square is equal to 5n. This is the one when R is taken as 0. Now, if R is equal to 1, then A is equal to 5Q plus 1. What is A square? 5Q plus 1 whole square. That is equal to A square plus 2 into A into B plus B square. Means 25Q square plus 10Q plus 1. So in this you can take 5 as common. 5Q square plus 2Q for these two. These two we are taking. Plus 1. That is equal to 5n plus 1. Therefore, A square is equal to 5n plus 1. We have got it when R is equal to 1. Now, we will see if R is equal to 2. If R is equal to 2, then A is equal to 5Q plus 2. A square is equal to 5Q plus 2 whole square. That is A plus B whole square. A square plus 2 into A into B plus B square. That is 25Q square plus 2 2s are 4, 4 5s are 20. 20Q plus 4 means in these two you can take 5 as common. 5Q square plus 4q plus 4, that is equal to 5n plus 4. Therefore, a square is equal to 5n plus 4. They have asked not to say 5n plus 4. You have got it. If r is equal to 2. Now, we will see if r is equal to 3. If r is equal to 3, then a is equal to 5q plus 3. A square is equal to 5q plus 3 whole square, that is a square plus 2 into a into b plus b square. That means 25q square plus 5 to the 10, 10 is a 30q plus 9. But here you want either 5n or 5n plus 1 or 5n plus 4. So what are we going to do it here? 25q square plus 30q plus 5 plus 4. 9 I have made it divided into 5 plus 4. So in this 5 is common. 5q square plus 6q plus 1 plus 4, that is 5n plus 4. Therefore, a square is equal to 5n plus 4 if r is equal to 3. Now, let me see the last one. If r is equal to 4, then a is equal to 5q plus 4. A square is equal to 5q plus 4 whole square. That means a square plus 2 into a into b plus b square. That means 25q square plus 5 5 4s are 20, 22s are 40q plus 16. 4 4s are 16. Again, 16 means what, children? You can write it as 15 plus 1. This can be written as 25q square plus 40q plus 15 plus 1. So in all these, 5 is common. 5 into 5q square plus 8q plus 3 plus 1. 5n plus 1. Therefore, a square is equal to 5n plus 1. So, what did you get from all this? Therefore, what you can say? What is the problem says? You have to show that square of any positive number. Therefore, square of any positive number is in the form of 5n, 5n plus 1, and what else they have given? 5n plus 4. This is what the proof. This is the problem, children. For 6 marks it is. Please go through it. Now, the next one. Now the next question, 9th one. Use Euclid's division lemma to show that cube of any positive integer is of the form 3p or 3p plus 1 or 3p plus 2 for any integer p. This is the question. So again, Euclid's division lemma, what is it? A is equal to PQ plus R, where 0 less than equal to or less than B. Okay. Now, according to problem, B is equal to 3. Therefore, what is our 0, 1, 2? So, if R is equal to 0, then A is equal to PQ plus R, that is equal to 3Q plus 0. So, A is equal to 3Q. You want AQ is equal to 3Q whole cube, that is 27Q cube. 27Q cube can be written as 3 into 9Q cube, that is equal to 3P. Therefore, A cube is equal to 3P. You have done the first one if R is equal to 0. Now, if R is equal to 1, then A is equal to BQ plus R, A is equal to 3Q plus 1. So what is A cube? 3Q plus 1 whole cube. A plus B whole cube. That is A cube plus 3 into A square into B plus 3 into A into B square plus B cube. So 3 into 3 into 3Q cube. This first one plus 3 into 9Q square plus 3 3s are 9Q plus 1. So take all this. In this you can take 3 as common. So here 3 has taken means 9Q cube plus 3 is out, 9Q square plus 3Q plus 1, that is equal to 3P plus 1. Therefore, A cube is equal to 3P plus 1 is the second one if R is equal to 1. Now, if R is equal to 2, then A is equal to P cube plus R, that is 3Q plus 2. A is equal to. So what is A cube? 3Q plus 2 whole cube. That means A cube plus 3 into A square into B plus 3 into A into B square plus B cube. I hope I'm clear, children. I'm saying ABC, but I'm writing the concerned values here. So this can be written as 3 into 3 into 3 Q cube plus 3 into 9Q square into 2 plus 3 into 3Q into 4 plus 8. Now, you want 3P plus 1 or 3P plus 2. That means 3 into 3Q cube plus 3 into 9Q square into 2 plus 3 into 3Q into 4 plus 6 plus 2. 8 I have divided into 6 plus 2. So in all this, I can take 3 as common. 3 3s are 9q square, q cube, not square. It is 9, 9q cube plus 3 is out, 18q square plus 3 is out, 3 4s are 12q plus 3 2s are 6 plus 2, that is 3p plus 2. Therefore, a cube is equal to 3p plus 2. So, you have seen 3p or 3p plus 1 or 3p plus 2. So, what is the solution that you will be written? Therefore, the cube of any positive integer is in the form of 3p or 3p plus 1 or 3p plus 2. So, this is what you have come to the conclusion for this problem, children. Please copy. Now, next one. Tenth problem. Again, the same thing. Same type of question. Use Euclid's division lemma to show that cube of any positive integer is of the form 7m or 7m plus 1 or 7m plus 6. Same type of problems, children. So, what is Euclid's division lemma? It says that A is equal to BQ plus R, where 0 less than equal to or less than B. According to problem, B is equal to 7. Therefore, what is R? 0, 1, 2, 3, 4, 5, 6. So, let us take. If R is equal to 0, then A is equal to BQ plus R, that is equal to A is equal to 7Q plus 0, A is equal to 7Q. A cube is equal to 7 cube whole square, that is 7 into 7 into 7 q cube. A cube is equal to 7 cube whole cube. So, A cube is equal to 7 into 7 into 7 q cube. So, 1 7 I have taken it out, that is 49 q cube. This is nothing but 7m. Therefore, A cube is equal to 7m. You have proved if r is equal to 0. Now, if r is equal to 1, then a is equal to b cube plus r. That means a is equal to 7 cube plus 1. A cube is equal to 7 cube plus 1 whole cube. 7 cube a cube plus 3 into a square into b plus 3 into a into b square plus b cube. So, this is 7 into 7 into 7 cube plus 3 into 7 into 7 q square plus 3 into 7q plus 1. So, in all these, 7 is common. 7 7 is 49 q cube, 49 q cube plus 1 7 has gone out. 3 7 are 21 q square plus 7 has gone out. 3q plus 1, that is equal to 7m plus 1. Therefore, a cube is equal to 7m plus 1. This you have got if r is equal to 1. Now, if r is equal to 2, then a is equal to b cube plus r, a is equal to 7 cube plus 2, a cube is equal to 7 cube plus 2 whole cube. That is equal to a cube, 7 cube whole cube plus 3 into a square into b plus 3 into a into b square plus b cube. That is 7 into 7 into 7 cube plus 3 into 7 into 7 q square into 2 plus 3 into 7q into 4 plus 8. Now, what I want, children? Either 7m plus 1, this is 1, or 7m plus 6. So, what can I do here? 8 can be written as 7 plus 1. So, 7 into 7 cube plus 3 into 7 into 7 q square into 2 plus 3 into 7q into 4 plus 7 plus 1. So, in all these, I am taking 7 as common. 7 7s are 49 q cube plus 7 is out, 3 7s are 3 2s are 6, 6 7s are 42 q square plus 7 is out, 12q plus 1 plus 1 out of 7. 7 is out means you will be having 1. This is nothing but 7m plus 1. Therefore, a cube is equal to 7m plus 1. So, this is up to 2 children. I need space for the other part 3, 4, 5, 6. So, write down this. I'll do the next part of this sum. If r is equal to 3, I should do. R is equal to 2, I have done. Now, if r is equal to 3, then a is equal to b cube plus r. That means a is equal to 7q plus 3. So, what is a cube? 7q plus 3 whole cube. That is a cube plus 3 into a square into b plus 3 into a into b square plus b cube. expansion of the formula. So this can be written as 7 into 7 into 7 q cube plus 3 into 7 into 7 q square into 3 plus 3 into 7q into 9 plus 27. 27 can be written as 21 plus 6. 7 into 7 into 7 q cube plus 3 into 7 into 7 q square into 3 plus 3 into 7q into 9 plus 21 plus 6. So all this we have to take 7 as common, 49 q cube plus 7 is out, 7 3s are 21 or 3 3s are 9, 9 7s are 63. So this is 49 q cube plus 7 is out, 7 3s are 21, 21 into 3, that is 63. Q square plus 7 is out, 3 9s are 27q plus 7 3s are, so 3 here plus 6. So this is nothing but 7m plus 6. Therefore, a cube is equal to 7m plus 6. You have got when r is equal to 3. Now, we need to go if r is equal to 4, then a is equal to pq plus r. That means a is equal to 7q plus 4. A cube is equal to 7q plus 4 whole cube. That is a cube plus 3 into a square into b plus 3 into a into b square plus b cube. That is 7 into 7 q cube plus 3 into 7 into 7 q square into 4 plus 3 into 7q into 16 plus 64. So this can be written as 7 into 7 into 7 q cube plus 3 into 7 into 7 q square into 4 plus 3 into 7q into 16 plus 63 plus 1. So all this, in this 7 you can take as common, 49 q cube plus 7 is out, 3 4s are 12, 12 7s are 84, q square plus 7 is out, 3 16s are 48, q plus 7 9s are 63 plus 1, that is 7m plus 1. Therefore, a cube is equal to 7m plus 1. So up to 4 I have done, children. I need to do 5 and 6. Please copy. Now, if r is equal to 5, Then A is equal to B cube plus R. A is equal to 7 cube plus 5. A cube is equal to 7 cube plus 5 whole cube. So again A cube plus 3 into A square into B plus 3 into A into B square plus B cube. So 7 into 7 into 7 Q cube plus 3 into 7 into 7 Q square into 5 plus 3 into 7Q into 25 plus 5 5s are 25, 25 5s are 125. So 125 means we have to divide 125. So we need to get either 7m means multiple of 7 is not 125. So 7m plus 1, 124 if you take, you don't get. So let us first divide 125 by 7. 7 1s are 7, 5, 5. 7 4s are 7 6 are 42, 7 7s are 49, 7 8 are 56, 7 7s are 49. So you'll be getting 6 out. So what you can write here? 7 into 7 into 7 Q cube plus 3 into 7 into 7 Q square into 5 plus 3 into 7Q into 25 plus 125 can be written as 7 into 17 plus 6. So 7 17 are, so if you want you can check children. 7 into 17 means 119. From 125 if you take 119 you'll be getting 6. So 6 I have taken here as the reminder. So this is how you can check how you can bifurcate. Now these all can be taken as 1. 7 into 7 Q cube, or I'll write it as 49 Q cube plus 7 is out. So 21 into 5, 105. 105 Q square plus 7 is out. 75 Q plus 17 plus 6. This is nothing but 7m plus 6. Therefore, A cube is equal to 7m plus 6. We have got it if R is equal to 5. One more is there. Anyway, the place is not sufficient. I'll do again, children. Please copy. Now, if R is equal to 6, then this is 7 cube plus 6. So A cube is equal to 7 cube plus 6 whole cube. That is equal to A cube plus 3 into A square into B plus 3 into A into B square plus B cube. That is 7 into 7 into 7 Q cube plus 3 into 7 into 7 Q square into 6 plus 3 into 7Q into 36 plus 6 6 are 36, 36 6 are 36, 18, 216, 216. So, how will you divide? We can take it as 210 plus 6. So, 7 into 7 q cube plus 3 into 7 q square into 6 plus 3 into 7q into 36 plus 210 plus 6. So, this all you can take as 1. 7 into 49 q cube plus 7 is out. 6 3s are 18. 18 7s are 126 q square plus 7 is out. 36 3s are 108 q plus 7 3s are 0 plus 6. That is nothing but 7m plus 6. Therefore, a cube is equal to 7m plus 6. So, what are we getting? Therefore, what you can say? Every cube of any positive integer is of the form of, what are they? 7m or 7m plus 1 or 7m plus 6. This is how you can prove this sum, children. Please copy. So I'll stop here, children. Remaining sums we will see in the next class once you copy this.